All right, so we have this function, f of x equals x plus 1 quantity squared times x minus 3 times x plus 4. And we want to sketch this graph. Okay. Now, the first thing we should do is we should just analyze this function, right? We should get the degree of the function. That'll give us the end behavior. We should get the zeros or the x-intercepts. And then using the multiplicities, right? All that combined together, we should be able to sketch the graph here, okay? So first of all, what is the degree of this polynomial then? Okay. So if you look at the factors of x right now, we don't write the power here, but we can assume this is a power of 1, right? This is also a power of 1. Right? Now this is the key here, right? This is x plus 1 squared, or x plus 1 times x plus 1 times x minus 3 times x plus 4. That's make this a 4th degree polynomial. Okay? Why is that important? Well, because it's an even degree. Okay? So what can we conclude if we know that this is an even polynomial? Right? The end behavior should go up and to the left and up and to the right. Okay? I guess I should mention there's no negative sign here, right? This is a positive. So it's a positive 4th degree polynomial. So it's going to be like a basic U shape. Okay? All right, next thing we want to do is we want to get our zeros, right? The zeros or the roots. Okay? So that we can get from the different factors, right? We can set each factor equal to 0. Right? So what do we get in this case? X plus 1 equals 0. We have x minus 3 equals 0, and x plus 4 equals 0. But notice what happens here, right? If x plus 1 equals 0, then x equals negative 1. X equals positive 3, and x equals negative 4. Now you notice here though, right? The multiplicity here is 2. And for all of these, the multiplicity is 1. Okay. So what can we conclude then, right? Well, let's just draw out the x-intercepts here. So remember, these are the x-intercepts, right? There's an x-intercept at negative 4. There's an x-intercept at negative 1. And there's an x-intercept at 3. All right, now we should be able to draw the graph, right? So remember, this is a smooth curve. It's going to be a U-shape. What happens at negative 4, though? Are we going to go through the graph, or are we going to touch it at negative 4 and bounce back? Okay, well, the multiplicity is odd, so we're going to go through. Okay. Now here we know that we have to turn around, right? That's called a turning point. Okay, so we're going to turn around and approach the next x-intercept here. But what's going to happen at negative 1? Are we going to touch it and then bounce back, or are we going to go through it? Remember, that's determined by the multiplicity. At negative 1, the multiplicity is even. So that means here we're going to touch the x-axis at negative 1 and then bounce back. Okay. Now you notice, where is the next x-intercept? Right? The next x-intercept is over here, so what can we conclude, right? Well, it has to turn around at some point and approach the x-intercept, but what's going to happen at 3? Okay, so at x equal to 3, the multiplicity is 1, which is odd. So it's going to go through the x-axis at 3, okay, and then everything should line up here, right? Notice the end behavior, right? The graph finishes up and to the right, so we should just connect this guy. Now I do want to mention this is a rough sketch, okay? So I know this doesn't really look, I mean, if you graph this on a graphing utility, it would look a lot different, okay? But the main thing that we are looking for is, do you have the correct end behavior, right? Also, do you have the correct x-intercepts, and do you bounce back, or do you go through at each x-intercept? Okay, so those are the main things. Okay, obviously, we can be a little bit nicer here with the graph. Okay, but actually, some students ask, how do we know how shallow or how deep we have to go with these 2 points here? Okay, so actually, in this class, that's not really important. And once again, use a little bit of artistic license here, right? Understand that these are nice, smooth curves, okay, and that it is a turning point. Okay, actually, these points we do find in calculus, okay? But in this class, just being as artistic and as nice as possible here. Okay, so those are the main things that you should be looking for in this class.